So, so my presentation today is the geoenvironmental engineering, evolution, challenges, and opportunities. Professor Javed asked me to introduce this geoenvironmental engineering topic, so just wanted to share kind of a high-level overview of what is geoenvironmental engineering, how it evolved, what are the challenges, and what are the opportunities. So before I get started, I want to thank again Professor Ali Javed for invitation and coordination of this webinar. And I also want to thank Dr. Pradeep Muley, Mr. Rohit Kumar, assistant professors in Civil Engineering Department for coordinating this webinar. And I want to also thank college administration for supporting such webinars. And I want to thank all of you for attending this webinar. So this is, I know I am presenting to this college for the first time, so I just wanted to introduce, myself and my lab before I get into the presentation. So I'm from Chicago. And so those who visited US, they know where Chicago is. And Chicago is a very nice place to visit. It's, a lot of us, for civil engineers, this is the city you can visit and admire what infrastructure is and what the environment should be like. So it's a nice place to visit. And the last two slides you see here, they are my university campus. So you are more than welcome to visit, next time when you are in, when you're coming to Chicago, US. So regarding my research, I am in charge of these two labs, Sustainable Engineering Research Lab and the Geotechnical and Geoenvironmental Engineering Lab. My research is on environmental remediation of soils, sediments, groundwater, and stormwater, work on different technologies to clean up polluted sites. And then also other area of my research is waste management and landfilling. That includes beneficial use of waste materials, landfill engineering, sustainable landfill liners and cover systems, biocovers, bioreactor landfills, and so forth. And the third area of my research is life cycle assessment and sustainable and resilient engineering. Here, I'm interested in developing sustainability and resiliency analytics frameworks that can help to quantify sustainability and resiliency. And once you have those frameworks, you can apply to any engineering applications. So I have applied to a lot of geoenvironmental problems. And then my area of interest also includes geotechnical engineering. So I worked in industry for 3 years, doing a lot of site investigations, structural foundations. My master's thesis in Roorkee was earth retaining structures. My PhD was on cemented sands, ground improvements, geomechanics, geotechnical engineering. So I do teach geotechnical engineering. I do some consulting in geotechnical engineering, but a lot of my research is in the first three topics: environmental remediation, waste management, and sustainable and resilient engineering. Of course, my undergraduate degree is in civil engineering. So this is my background. This is what kind of research that I do. And whatever research that we have done in the last 25 years, that has been summarized in these 4 books and these journal papers and conference papers. You can get onto my website to get more details about these publications. So in our lab, our research philosophy goes this way. So we identify a real world problem and we come up with a hypothesis of our solution. And then we do bench scale testing to see if it is feasible or not. So if it is feasible, then we do the large scale lab testing and find out more about our solution. And then we do the modeling to incorporate those fundamental processes that we learned from lab testing. And based on the modeling, we designed field scale systems. And then we, try it out in the field and see, what we came up in the lab works in a real world scenario. So which is very important, taking your research concept from lab scale testing to modeling to field scale testing. So, and our goal is to learn the fundamentals. We are in the university, we are going to advance the fundamentals, but at the same time, our goal is to advance those fundamentals towards coming up with a practical solution to the real world problems. So that's kind of a philosophy we apply on every project that we work on. So I do a lot of experimental research. This is our lab. You can see soil and material testing equipment, geochemical characterization equipment, geochemical testing, and bench scale testing. Depending upon project, we use different equipment. We fabricate the equipment depending upon the project. So over the last 25 years, I had the pleasure of working with students from all over the world. They come, being in the US, we get students from different parts of the world. It's so nice to work with all these talented students, and a lot of my accomplishments are due to the hard work of all these students. So regarding the presentation today, as I said, Professor Javed asked me to talk about the geoenvironmental engineering. Since I don't know, the background of the audience, I wanted to introduce this geoenvironmental engineering field in general terms. I'm not going to go into a lot of technical details, but at least you need to have this overview in order to appreciate, the detailed research that is being done in this field. So I'm going to explain what is geoenvironmental engineering, how it evolved, and then I'm going to talk about geoenvironmental engineering challenges and the geoenvironmental engineering opportunities, and then closing comments. So I know, many of you may be having civil engineering background. As civil engineers, we design, build, maintain the foundation for our modern society, right? So we do a lot of infrastructure development, buildings, roads, bridges, drinking water and energy systems, seaports, airports, infrastructure for cleaner environment, and many more like this. And in addition to civil engineering fundamentals, like this, that we get in undergraduate level, civil engineers often specialize in one of the following technical fields via years of practice, or through advanced degrees like MTech or PhD. So you often know these specialty fields in environmental engineering, geotechnical engineering, structural engineering, transportation engineering, and water resources engineering. These are kind of more common specializations, but there are many more specialty areas. And out of this one, what we are talking about is the geotechnical engineering. So a lot of you are, civil engineers or geotechnical engineers. You should have been familiar with what is geotechnical engineering is. Geotechnical engineers do site investigations, right? Subsurface, to find out the subsurface conditions for any project. That's the first thing that you need. And then you design the foundations. Every civil engineering structure needs a foundation: roads, buildings, machines, whatever. You cannot have a civil engineering structure without a foundation, so we need that. And designing the earthworks for dams, levees, roads, tunnels, and underground structures, we do that. And investigating the land mass problems such as landslides, slope stability, subsidence, and all those things. So these are all, very important responsibilities, and these are all needed for infrastructure development. You cannot imagine infrastructure development without the role of a geotechnical engineer. So what happened over the years is, we have built a lot of infrastructure. And I want you to look at this graph on the issues with the way the development is going on or has been going on. So on x-axis, you see human development index. On the y-axis, you see ecological footprint, right? So this 0.8 human development index more than 0.8 is, any country that has more than 0.8, it's a developed country. So less than that is a developing country. Now, if you look at, ecological footprint, so the planet Earth has certain biocapacity, that's the capacity it has, it could recover from that. And that capacity is shown by this line here. So world average biocapacity available per person. So ideally, you want to be a developed country, but you want to be within the biocapacity of the planet. So that means you want to be in this quadrant. This is called sustainability quadrant. And as you see, there's, I'm showing this data for different countries. There's no country that is within this. Now, for example, US is a highly developed country, and but a lot of infrastructure that is built has caused a lot of ecological damage. And you can see the Canada, you can see a lot of European countries. So all these developed countries build their infrastructure at the cost of this ecological damage. So there are a lot of developing countries, they want to follow the path of developed countries, and that is not a good sign, because if you go follow these developed countries, you're going to have the development with a lot of ecological damage. So I think this is China and India are here. So the point here is, we have been building infrastructure without any regard to ecological or environmental damage. And what does that mean? So we don't care about depletion of natural resources. We think, the resources are infinite. That's not the case. And we are creating a lot of waste every year. And we are increasing the pollution and increasing the greenhouse gases and causing a lot of climate hazards. And then we ignore the life cycle sustainability. Can we maintain this one into the future? So these are the concerns. So now we are at a point that we cannot have a development without considering these ecological and environmental damage, because we are feeling the impacts of these damages, and as a result, everybody is focused on sustainable infrastructure. So in the US, in 1976, there's a new law called Resource Conservation and Recovery Act. And that addressed the problem of recycling, and then issues related to disposal of the waste and the need for engineered containment facilities. So you can see in the US, these environmental considerations started to be discussed, in 1976 with this new law. And then in 1980, there is another new law passed by the government, and this is called CERC law or Superfund, that is aimed at cleaning up the contaminated sites, including the dump sites, because they were posing a lot of health hazard to people and the environment. So when these laws were passed, you can think about these two things. Here is the engineered containment systems and recycling in this law, and this law deals with the cleanup of contaminated sites. So you can see there are a lot of geo aspects involved in it. Engineered containment is like a landfills, that deals with the soils. Recycling, basically, substituting the soils with these waste materials, and cleaning up contaminated sites is soils and groundwater. So, geotechnical engineers have the background on earth materials and groundwater, so they started to, play an important role in characterizing and reuse of waste materials. Instead of using soils, can we use the waste materials? And design of containment facilities, landfills to manage the waste, and investigate, design, and clean up of contaminated sites. So this is, I feel that, this is the time when geotechs were, starting to get involved in this environmental issues. US EPA developed regulations and technical guidelines for these kind of tasks, like recycling, waste containment systems, and contaminated sites. And many geotechnical engineers have contributed to the development of these regulations and technical guidance documents. And that's when, we started to see this geoenvironmental engineering, um, you know, began, in civil engineering field. So in the early days, it used to be combination of geotechnical engineering and environmental engineering. So environmental engineering were there, engineers were there, geotechnical engineers were there. But this, the role of geotechnical engineering, early days was to apply traditional geotechnical engineering, such as settlement analysis, slope stability analysis, seepage analysis, something you learn in geotechnical courses, to geoenvironmental problems. For example, slope stability of a landfill liner system. So you can basically, you look at conventional slope stability analysis that you have done, you apply the same thing. Settlement concepts are also applied for example, calculating the settlement of waste. So these are all like applying the traditional geotechnical engineering to environmental problems. Now, then, later, people started working on the groundwater issues. So, environmental engineers generally deal with wastewater, water. They don't deal with, groundwater. Then, water resources people or, hydrogeology people got started involving. So, this became, important. So, still, geotechnical engineers were playing the role of they're using their geotechnical engineering background to provide the analysis of uh, you know, conventional aspects like settlement, slope stability, seepage. But later on, it is realized that this environmental geotechnics is just providing your geotechnical services, but geoenvironmental engineering is much broader than that. So the geoenvironmental engineering is the way we want to define is it's an application of all relevant multidisciplinary knowledge to understand and develop engineered solution to the geoenvironmental problems. It's not just applying the geotechnical engineering background, but it is all the background that is needed to really solve the geoenvironmental problems. So, I've shown you this circular diagram, geoenvironmental engineering, that basically deals with environmental characterization, risk assessment, containment, remediation, waste management, sustainability, right? These are the things that we are interested in. To understand, to address these issues, you need to have these multiple disciplinary background. Geotechnical engineering is, of course, is very essential. And then you need environmental engineering. Then you have geochemistry, hydrogeology, microbiology. These are all the things that are needed. I didn't show different sizes for different fields. So obviously, geotechnical engineering plays a major role. But you need to have this background with other things, other subjects. So it's truly a multidisciplinary technical approach, and now, this word geoenvironmental engineering is used much more commonly than environmental geotechnics. So the environmental geotech is, as I said, just a conventional geotechnical engineering applying to environmental problems, but geoenvironmental engineering is looking at the problem holistically, trying to solve the problem with all the multidisciplinary knowledge that is needed. So the geoenvironmental engineering is nothing but designing and applying engineering solutions to the problems that we deal with in geoenvironmental engineering are non-hazardous and hazardous waste management, characterization and mitigation of contaminated sites, and enhance the environmental sustainability and resiliency. These are kind of a broad, challenges, that need solutions, and the geoenvironmental engineering provides this. And again, these solutions, if you have just a geotechnical engineering is not enough. So you need to have a geotechnical engineering, soil mechanics and rock mechanics, and then hydrology and hydrogeology, geochemistry and biochemistry, contaminant transport and transformation, human ecological health risk. So if you have all these things, then you can come up with a holistic solution to the geoenvironmental problem. So again, I want to mention this one clearly because people use environmental geotechniques and geoenvironmental engineering. So I wanted you to distinguish between these two terms. So environmental geotechnics is a narrow focus, whereas geoenvironmental engineering is a broad focus, and I prefer using geoenvironmental engineering um, all the time. And also, how you write a geoenvironmental engineering, a lot of people write different ways. I always show this one to make sure that everybody writes it in a proper way. Now, question is, okay, in geotechnical engineering, we learn only, soil mechanics and, rock mechanics and other geotechnical subjects. How do we acquire the knowledge that we need? You're talking about, microbiology, you're talking about hydrogeology, how do I get all this background? So I know in the past it was difficult to learn these things, but in the recent curriculum, if you look at many universities, they're offering these courses, and they're offering geoenvironmental engineering courses where they teach some of these concepts that are essential for understanding the geoenvironmental problems and solutions. So the students now, in universities are able to get that background from the courses, geoenvironmental engineering courses. And then, not only that, now we have textbooks available to be able to read and learn the relevant, uh, non-geotechnical engineering background that you need here. And students are also given option to take courses outside the major. I don't know about universities in India, but here we give the flexibility to civil engineering students to go and take a course in microbiology or public health. So we give that flexibility for the students to take the courses. And also, if you are doing research, if you need a microbiology background, go to the microbiology department and talk to a colleague and have the collaboration going on. So in the process of collaboration, you learn, things, both ways. They will learn what we are doing, and we learn from data. At least, some basic concepts would become clear. So this has been my experience, and it's not difficult to get the experience that you need. So in terms of the teaching, geotechnical engineering courses are taught in many universities. In my university, I teach these courses. Um, and then in addition to geotechnical engineering courses, we teach geoenvironmental engineering courses. So this first course is an introduction to geoenvironmental engineering. We teach this one for undergraduate students. And then you have, other courses. And then we have also sustainable engineering course here. So I know a lot of universities in India are also starting to teach these geoenvironmental engineering courses. And the need for these courses, is there, and more universities should be teaching these courses. So if we teach these geoenvironmental engineering courses, and in addition to geotechnical engineering courses, we are preparing the students to learn both infrastructure development and also, looking at the environmental issues. So, that way they are well prepared to develop the infrastructure that is more sustainable and environmentally friendly. And you may be seeing this trend, master's program or PhD program. Now they don't call geotechnical engineering, they call geotechnical and geoenvironmental engineering to emphasize the fact that geoenvironmental embraces a lot of things that are not covered in geotechnical engineering. So if you are offering geoenvironmental engineering courses, you may want to call your program as a geotechnical and geoenvironmental engineering. And this is the textbook that I use for teaching 3 geoenvironmental engineering classes. So introduction to geoenvironmental engineering. I teach landfill design. I teach polluted site remediation also using this book. Now that's the background about what geoenvironmental engineering is. For me, geoenvironmental engineering is kind of fascinating, and it's very important that you know uh, field to work on, because we have a lot of problems and challenges that are not yet addressed. So one of the problems is the MSW management, municipal solid waste management. Municipal solid waste is a fancy word, but it's all the garbage that we throw away from our houses and in commercial facilities, institutions, and so forth. And you've probably seen this garbage, lying around, on the roads and other things. But the best way is to collect them and dispose them, but not dispose them in a dump site like here. These are the cases that you see in India. So the waste is collected and taken to a dump site and you dump it. This is no. I mean, there are so many issues. I mean, obviously, visually you can see, the fires and the gases, and some, nasty liquids coming out of these waste. You see these kind of problems, visually, but there a lot goes on, that you don't see it. So when it rains, the water goes through the waste, and it leaches out all the contamination, and that contamination goes down into the groundwater, and then groundwater gets contaminated, and then groundwater keeps on moving, and then you might have your drinking water well contaminated, surface water could be contaminated, and people could be exposed, and even the rainwater that goes as a runoff could contaminate the nearby crops, nearby houses, so forth. So there are a lot of the things that you don't even see it. They are going to cause a lot of problems. So dump sites, should not be allowed at all, because not only the visual problems that you see, but there are a lot of non-visual, very serious problems you have with the dump sites. So all the youngsters, listening to me from India, should realize that the dump sites are going to cause more and more problems going into the future. So the problems are not going to go away, and they're going to increase more and more. Now, hazardous waste, these are the waste that companies generate. Okay, so of course you have a lot of manufacturing companies in India, and you need to look at them and see where are they disposing their waste. So very few companies may be disposing them in hazardous waste landfills that are designed, or they are doing recycling. Perhaps most of the waste may be disposed improperly. So if you dispose the waste improperly on the ground or below ground, the soils are going to be contaminated, groundwater is going to be contaminated. Eventually, we are the ones, people are the ones who are going to be get exposed, and we're going to have a lot of problems with this exposure. So that is the issue that we need to address. And then other problem is the nuclear waste. And people, that nuclear waste is considered as a clean energy. But the problem is, it creates the waste that's hard to, dispose of. And so, even though we consider, nuclear energy is carbon free, doesn't have any greenhouse emissions compared to, fossil fuel based energy sources, but this nuclear waste needs to be, managed properly. So how do you manage that one? So it's a big problem. So if you want to bury them, you need to have a very sophisticated liner systems, so that surrounding environment is not affected. And mine waste, there's so many mines in India and all over the world, and some of the mine waste is not environmentally friendly. There could be highly alkaline or highly acidic. They could have a lot of contaminants. So you need to ensure that these facilities are physically stable. Not only that, contents are contained. If you have releases, large area is going to be contaminated, and cleaning up that is very difficult. So you're going to affect the people, you affect the land. You're going to have a lot of issues with these kind of things. And then I know coal mines. There are a lot of coal mines in India too. So the coal mines can also pose a lot of the environmental issues that need to be addressed. So when you even, at coal powered plants, you create this coal ash that is generally disposed in the ponds. And then a lot of these ponds don't have any liner system at the bottom. When you put in the ponds, what happens? They will infiltrate into the ground, and the groundwater gets contaminated. And then if you have a drinking water or something like that, it goes by, that's going to get contaminated. So there's a big problem with this disposal of, the coal ash, or, a lot of this mine waste that you find. The other problem is with the industrial byproducts. So like such as steel slag, carbide lime, bauxite residue, fly ash, and granulated blast furnace slag. These are all the byproducts that are generated. Every year they generate large quantities of these. And these are often disposed in, on site or off site. And, so this is kind of, you not using the resources properly. So this is the, these have a good value. Um, and yeah, and we are just treating them as waste, and we are disposing them, in landfills, or dump sites, or the close to the plants where they are being generated, right? Are you able to hear me? 1 second, can somebody confirm if you can hear me or not?
Yes, sir.
Okay. Okay, very good. Thank you. All right. So that's the problem. We need to, make use of those wastes, instead of just considering them as waste and dumping them, we need to see if we can use them as valuable resource materials. The other problem that we have is a contaminated sites, polluted land. And what happens is, if you don't dispose of your waste properly, then you're going to see all kinds of problems. Sometimes you bury things so that people don't see it, and they will always infiltrate into the ground, and soil is contaminated and groundwater is contaminated. And in very few cases, you see something on the surface. So these photos show something that you can see on, at the surface at some sites. And these could lead to a lot of problems. As I mentioned, soil is contaminated, groundwater could be contaminated. Eventually, people are going to be exposed to this contamination, and can lead to a lot of diseases. All right. Okay. So the other problem that I want everyone to pay attention to this. This is kind of a huge problem that is um, everybody's talking about, is the climate change, right? And the climate change is due to greenhouse gases. And there is a well-known fact that greenhouse gases means what? Carbon dioxide, methane, nitrous oxide, and the CFCs, HFCs, and they are increasing, right? And the climate change is happening due to this increased greenhouse gases. And we have increased so much that it's hard to reduce them very quickly. So what do we do? So since these are already very high, and we are not doing anything substantial to decrease them, as a result, they continue to increase. And as a result, we are going to have climate change. And that leads to a lot of climate change hazards. And you can see some places it's extremely dry, some places it's extremely wet, a lot of flooding, very intense storms, a lot of unusual, weather and climate impacts. sea level rise, wildfires that are going on in California, here in US, very common. And you see in India, there's a lot of flooding that's going on. This never used to happen in some places, and these things are happening. So this a lot of these unusual, things are happening. Those are all attributed to the climate impacts, and that can, cause a lot of environmental issues too. When the area gets flooded, some places, these garbage disposal dump site, all the garbage, gets distributed into the residences and other places. This is a huge problem. And even coastal areas where you have these industrial facilities, as the seawater rises or hurricanes, come there, then you have a lot of damage, and that is causing a lot of environmental issues too. This is a huge problem that people are thinking about it. Whenever you see some strange weather that happens, which was not happening in the past, and it's happening more and more, that is due to these greenhouse gas emissions. So we need to do something about greenhouse gases. Again, as I said, you have excessive flooding that can, even release the contamination from containment facilities, right? So that's a big issue that needs to be considered. And we are not doing a good job in addressing that issue. The other challenge I want to mention is, again, this is going to be a very concerning for everyone, is the population growth, right? So as the population has been growing, exponentially. Right now we have 7.8 billion, and it's going to, increase significantly. Okay, some other estimates, show even much more than what I'm showing here. Now, what is the problem, right? So the problem is, this greenhouse gases that I mentioned, that really correlated to, population. The population is more, greenhouse gases are more. And as a result, we're going to have these extreme climate impacts. That's a big problem. And depletion of natural resources. Everybody needs a phone, right? So if making a phone requires a lot of natural resources, and we have only limited amount of natural resources, and once we run out of that, we're not going to have, these companies cannot make phones anymore. Increased waste generation. Everybody wants to throw away stuff. So if I have 5 people in my house, that's different. If I have 10 people, it's going to double the waste, right? Increased pollution. A lot of people on the road, everywhere, driving a lot of vehicles. So that's a pollution. Damage to ecosystem. We are building, everywhere, disturbing the ecosystem. Loss of biodiversity. We're, taking out all those areas for construction and, damaging the biodiversity. Urban sprawl, like the city, where you live. The city used to be small. Now it has spread so much, kilometers and kilometers. So that's a big problem. Economic disparities, not only in India but throughout the world. Poor people are becoming poorer and poorer, and then rich people are becoming richer and richer. So the disparity between poor and rich is growing quite a bit. That leads to a lot of issues. Social injustice. A lot of contaminated sites are in backward areas. A lot of landfills are in backward areas. A lot of dump sites are in backward areas because the people in those areas, they don't have a voice. But where you see people, rich people, they don't have any issues. So these are all the problems that come with population growth. You can imagine as the population keeps on increasing, all these problems are going to be multiplied, not going to decrease. So it's a concern that basically, whether future generations can meet their own needs or not. even, we are feeling, the impacts of greenhouse gases and climate change. Um, and, future generations are going to feel all these impacts much more. So that's why the sustainability and sustainable development has become very important. And geoenvironmental engineering can play a role, substantial role in addressing many of these problems. So these are the sustainable development goals that UN came up, all right? Because of these concerns that we have, we should take the actions to achieve some of these goals, achieve these goals, actions towards achieving these goals. So anything that we do, it should be contributing towards these goals. Again, civil engineering and geoenvironmental engineering can play a major role in contributing to these sustainable development goals. So we need to think about, we may be doing a small project, but if in some way it can contribute to one of these sustainable development goals, you are doing good for the planet overall, or, for humanity, you're doing something. So to summarize the challenges, I just want to I mentioned all of these things, how do you manage the waste, right? So that's the big problem. So we create all these wastes. We need to manage these wastes, otherwise we're going to be in big trouble, right? How to clean up and reuse polluted sites. How to mitigate greenhouse gases and address climate change impacts. That's called resiliency. How to achieve enhanced environmental sustainability and resiliency in any engineering project, but here we are dealing with geotechnical and geoenvironmental engineering projects. So think about these challenges as the challenges that require urgent research. So I know sounds depressing because we have a lot of challenges, but if you are a researcher, this is an exciting time. These challenges provide a lot of opportunities for research. If I'm a master's MTech student or PhD student, if I'm looking for a research topic, any one of these topics will be an excellent topic, because not much has been done on any of these topics. And then if you are a practicing engineer or you want to go into consulting, and a lot of work needs to be done by consulting engineers, right? Research is one thing, but you need to put things in practice. So there are a lot of opportunities for startup companies or consulting companies to get into addressing these geoenvironmental problems. In US, we have some companies that are very famous for doing the geoenvironmental engineering projects, design of landfills, contaminated site remediation, these kind of things. So a lot of students are hired by those companies. So I don't see that one happening in India. I'm sure it will happen, very soon in the future. So how do we address these challenges? What are the opportunities? How do we go about doing these things? Okay, I'm going to go over this one again, very in general terms. So waste management. This is one of the big issues that we need to address in geoenvironmental engineering. And everybody who works in waste management, they show up with this waste management hierarchy. We should be preventing it, minimizing it, reusing, recycling, energy recovery, disposal. And we are so much concerned about prevention, minimization, reuse. Not much is happening, and then a lot of waste is actually going into disposal. Ideally, we want to do those prevention, minimization, reuse, but just focusing on those top things, not able to accomplish those things, eventually all the waste is being disposed. But rather than that, instead of hierarchy, we need to look at integrated way. I always say that, okay, we need to keep all these options in our disposal and do whatever you can. Don't say that, I should do this one first, this one first. Do whatever you can, right? Whole idea is, not to dispose in a dump site. So you collect and sort it, and then do the material recycling, right? And then you have a biological treatment, thermal treatment, and you ultimately last one, landfill. But in a given situation, you might need all of them, right? So materials recycling, that's where geotechnical engineers, geoenvironmental engineers can play a major role. And landfills, geoenvironmental engineers play a major role. Materials recycling, I cannot overemphasize, the need for reusing these materials. We create so much of these materials, we are wasting these materials. And we know that we don't have, infinite amount of soils like sand, we are running out of those resources. We should be using these materials and conserving those natural resources. So in our lab, in my lab, with my collaborators, I worked with all these materials, and our goal is to find uses for these things. So now the concept is zero waste or circular economy. You probably heard about circular economy. What is it? Basically, linear economy is this. Basically, you use it and you throw it. It could be going into the incineration or to a waste dump. That's it, one-time use, and you dump it. Whereas zero waste or circular economy is where you take the material and you manufacture it and you use it, and instead of disposing it, you recycle it and then put into reuse. So you don't do any landfilling or incineration. So, the materials are being recycled all the time. So it's called circular economy. And there's a lot of emphasis on circular economy in the waste management field. One thing I want to mention is, we work, a lot of geotechnical engineers I know in India also, they work on waste materials. I've seen a lot of papers. But what we need to do is, we need to create a lot of applications, actual applications for the materials. So the way we do it in US is this, okay? Like at least, in our labs, we do this thing. So we identify the waste material suitability for intended applications. So based on the general properties, what kind of, applications that is suitable? Is it a drainage material if you have high permeability? If there's a low permeability, you may have like, liner systems or some other, subgrade system or something like that. Then you establish the lab testing protocol, because conventional soil equipment may not be suitable for testing these materials. And then you perform the testing and you get the results, and then see if they meet the requirement or not. If they don't meet the requirement, don't give up. See if we can modify that material with something else to make it to meet the criteria. Once it meets the criteria, do you need a field demo? Because you want to use it in the field, but you don't want to tell people to use in unless you know that it's going to work in the field scenario too. So do you have to do some field testing? If it is needed, you do the field testing and monitor, provide that data, and then you apply. You basically can whatever the agency that is involved in approving that material, you just apply for that one. And then identify implementation constraints. I know I want to use every waste material that is possible, but if the waste material is not available close to the site and you have to transport long distance, that's not going to be possible. So you need to identify what are the constraints of using that material, and then you do the performance sustainability assessment, where you look at broader environmental impacts, economic impacts, and social impacts, and then you recommend that use for that application. So I've seen very few recycled materials are successfully used for beneficial purposes. A lot of research is just characterization and submitting the papers, but they don't do full-scale field demonstration or establishing the standards for using them for different applications. So there is a lot of scope for characterization of these waste materials. I know geotechnical characterization is important, but also you need to think about environmental and durability issues, because a lot of these materials might have toxic metals. Are they leachable? Do you have some? Are they leachable? You need to look at those aspects. And then you need to demonstrate that they can be applicable, right? And also inexpensive. If it's going to cost more than using conventional material, nobody is going to use it. You want to demonstrate the performance, equal to the standard material and cheaper than the standard material. Then people use it. And you need to develop standards and design guidelines for all of them both. Now, other one is the landfills. Now, in India, as far as I know, for garbage, you don't have a landfills. I know people call these as landfills, but these are not landfills. These are all dumps. And you should not be allowing these dumps. And as I showed you before, we used to have this situation before in US that led to a lot of, soil, groundwater, all kinds of air pollution issues. So, in US, we don't have any dump sites. And whatever dump sites we had in the past in the US, they all, capped. They put a cap on the top, as you see here, and put the vegetation. And then to contain the leachate, they put a slurry walls. And then to control the head behind the slurry walls, you probably need a pumping well. So this is how you basically you contain it, in the location where it is, and it does not have any effect on the groundwater or surrounding. And then, if waste is not degraded properly, you need to have a gas management system. And then, you put once you put the vegetative cover on the top of it, it looks like this. People don't even know that it's a landfill. So it's like a hill. This is one of the landfill sites, dump sites that was closed. And you can also have, instead of this park like this, you can have other uses also possible. And these are like hilly areas, and then this became a tourist attraction. People want to go on the top of this one and then have a good view of the city. And then other option is if the waste is completely degraded, organics is completely degraded, and you don't have any contamination in the waste, maybe you can do this mining. Basically, you screen the materials and then use whatever you can. And the final material you can again dispose it off, use it as a final cover in the landfill, other things. But in US, we don't have a lot of mining projects. Most of the mining projects are done to create more space at the existing landfills. And generally, these don't come out to be, cheaper. The value of, the resources that you get by mining, is not as much as the, expense, you incur doing these things. So that's about, the waste dumps and the waste that you have. But going into the future, you should not be putting, any waste into the existing dumps. So you should be thinking about engineered landfills. So this shows, you can dig down into the ground and put a liner systems. You could have, surface impoundments if you have a liquid waste, and you can have, this animal waste, you can have ponds too. And then these are the engineered landfills. So you have a final cover, bottom liner, side liner, leachate collection system, and then you have a final cover. So you have a very good engineered system that are used in the US. So, but you need to think about it. I put this question mark because what we follow in the US, you should use that information as the basis, and then you can design your own engineered landfills based on the resources that you have. If geotechnical engineers work a lot with geosynthetics, and geosynthetics can be used for landfill components extensively. So you can use in the bottom liner, side liner, leachate collection system, and the final covers. So if you worked in geosynthetics, so you can use them in a creative ways. But the only thing is, are these geosynthetics, easily available for use or not? If you have to import, some of these things, cost associated with this, too much. So again, you need to learn what is being done elsewhere and then see what is possible locally. And not only, you have a bottom liner, side liner and the leachate collection system, but you have to have that leachate, kind of treatment, okay? And then you have to have a gas collection system. The waste is going to degrade because of the organics, and then you need to have a gas collection system. And then you also have to have a groundwater monitoring wells so that nothing is leaking. If something is leaking, you can detect based on this groundwater monitoring wells. So I teach a course on landfill design. I use this book, and then practice is well established. I'm just showing you liner and leachate collection and removal system construction here. So this is pretty standard in practice. And then Base placement, compaction, and daily cover. They put this one. Again, it's very commonly done. And once reaches the capacity, you cover it and then use it for beneficial purpose. I'm showing here this landfill is being used as a golf course, and a lot of rich people come there and pay. So you are actually generating the revenue out of this closed landfill. This is another landfill, that's closed and converted into park. Again, there could be a lot of creative ways to use the land instead of getting it wasted. So in the US, we're still working on some research issues. That's not so much in terms of um, changing the design in a substantial way, but making it more effective. So we have a problem of slow degradation, leachate treatment, fugitive gases, sustainability. So we are trying to address these issues through our research projects. I do some research on bioreactor landfills, biocovers, sustainability. So, but in terms of the practice, the design and construction of landfills is well established, and the monitoring goes on, and then these are very commonly used, and they are working very well. So my question is, take all these things that are learned that are happening in the US or other countries, and then think about what kind of effective and sustainable containment systems that can be built in India or in any developing countries, and then develop the standards and design guidelines so that if you want to follow what is being done in US, and if you don't have resources, you're not going to have landfills. You're going to create more and more dumps. So try to be realistic and see what is possible to be done, and do those things and avoid these dumps. And land pollution is a big problem. And in the US, we used to have these problems, starting from Love Canal, and some high visibility, contamination issues. What is the problem with these contaminated sites? Because it is pollutants. What do you mean by pollutants? These are all chemicals, inorganic chemicals and organic chemicals, and they are very toxic. That's the problem. If they are exposed, humans are exposed to these contaminants or in the environment, you're going to have a lot of issues. So in the past, we didn't have any laws and regulations, and these wastes are being disposed, and that's how they entered into the soil and groundwater. We have a lot of problems. And now we are remediating those sites. For example, on the left side, you can see the site was contaminated, and the owner didn't want to remediate, so he left that place, and then the government takes the land and then cleans it up and puts it into good use. So it's very important to clean up the sites. To clean up the sites, you need to do the site characterization that the geotechnical engineers are familiar with. Risk assessment, that's something that needs to be learned. And then you need to have a different technologies to remediate these contaminated sites. So we use different technologies, and some of the stuff you use come from conventional geotechnical engineering. So for example, vertical barriers, these are slurry walls. And geotechnical engineers are familiar with slurry walls for a seepage control, right? It's kind of the same thing. We do it, and the only thing that you have to make sure is that you don't have water, but you have a chemical solution. Make sure that backfill maintains the low permeability even when it gets exposed to the chemical solution. And then you have here final cover capping that for the dump sites, you put that one. And there are different technologies for cleaning up the soils and groundwater. This is a very interesting field to work on. Some of the technologies, as I said, pump and treat, and electrokinetics. These are all, researched by geotechnical engineers first, and then, more and more environmental issues were addressed as the research progressed. But in the beginning, it was done for geotechnical purposes, for dewatering, and other purposes. So these are the technologies, and you need to match the contamination and soil conditions to the technology. So you don't have one technology that can work everywhere. So you have to match it. Let's say if I have a sandy soil, or if I have a silt, if I have a clay soil. So you need to really think about soil conditions, So that's a geotechnical engineers can think about the soil conditions. And then if you have a contamination, background a little bit, then you can match the technologies properly. So in my research, we do, this understand the geochemistry and biogeochemistry, and then we try to engineer the technologies to meet the remedial goals. Again, this book that I use to teach a course on remediation engineering in this course. So again, in India, this contaminated site remediation hasn't gotten a lot of attention. I know there are a lot of sites. We need to have good techniques to do the site characterization, right? So first thing is you need to know, if the site is contaminated, how much site, what kind of contamination you have, and then you have to do the risk assessment based on the socio-economic conditions, and you need to think about remediation technologies based on contamination that you have, based on the resources that you have. So again, learn from what is done in other countries and then tailor them to meet the local needs. Now, coming back to this third category of challenges that provides the opportunities is climate mitigation. Remember, greenhouse gases are the biggest problem. So how do we minimize the greenhouse gases in the atmosphere? So one of the things is the plants. If you grow the plants, they will sequester CO2, right? And then, that's the way to sequester in the soil, right? So there are a lot of ways that here you need to have a plant soil interaction and the fate of CO2, what happens within the soil. The other option is, deep underground storage, right? So there's actually one project close to in my state where they inject the CO2 into the deep underground aquifer, and they want to store in that deep underground storage aquifer. So instead of emitting into the atmosphere, so you capture that one and then put it underground. So that way you can reduce the CO2's emissions in the atmosphere. So there's a lot of geotechnical engineering plays a role in these things. There are other ways to mitigate the greenhouse gases, but these are the ones where the geotechnical engineers plays a major role. But these are not going to make a lot of difference. They're not going to reduce the greenhouse gases overnight. We're going to see these extreme climate impacts more and more. So we need to design the systems that can cope up with these extreme events. Okay, so you design something, and let's say you have extreme flooding, and it gets damaged a little bit, but not not to collapse, but it will maintain some minimum performance requirement. And then after that extreme event recedes, then it recovers. And then, in ideal situation, you want it to perform same as how it was before the event, or even better than that. So what we are trying to do now is take into consideration of, these extreme flooding, extreme heat. These things are going to happen. We cannot do anything about it. But whatever I design, can it withstand these extreme events? So there's a lot of these things are going on. This is called resilient design, or climate adaptation, or design for climate change. So for example, this is the, landfill site right next to the river. And then if the river or coastal area, if the sea level rises, or, the surge, height is increased, if you don't have any protection, this is going to erode, all the waste is going to be, spreading. So now, because of that, anticipated climate change impacts, so they're putting this, shoring to prevent any kind of damage. A lot of people are doing modeling, to, okay, what happens if I don't do any protection, and if I do some protection, what happens to my water levels along the coastal areas? There are a lot of interesting work is going on in this area. As a geotechnical engineer, you should also look at foundations, right? So this is the New Orleans. So they estimated the flood in the future flood water is going to rise this much. So instead of putting the foundation at the ground level, they elevated the foundation, elevated the whole building, so that when it floods, the the height is, more than flood level, so the house does not get flooded. So again, this is the thing that's going on right now, to think about these climate impacts, because we cannot reduce these climate impacts. These are going to continue to happen. How do we, get out of this situation, at least temporarily? I mean, maybe in the long run, we could decrease the greenhouse gases. Maybe we don't have to do as much of this adaptation. So this is another project, this is the train line that goes from Los Angeles to San Diego in California. And this is the existing thing. And this is the river, this is the ocean right there. And for the predicted sea level rise, this is going to be submerged. So what they are doing is, okay, this is the existing one, because it's going to be submerged, this needs to be at higher level. So they are putting the jacks and see how they are, increasing the height of these piers, okay? And they're going to putting on the top of this, okay? So that's what, you need to design systems that can be modified to accommodate the future impacts, So a lot of people are looking in that direction. So that's about greenhouse gases. So this is greenhouse gases and climate impacts. So coming to the last issue is the sustainable engineering towards sustainable development goals. Now you need to think about anything we do in geotechnical engineering or engineering in general, we need to be looking at the sustainability. Sustainability definition, functional definition is this triple bottom line. We need to be looking at the environmental impacts, economic impacts, and social impacts. Among the environmental impacts, we have greenhouse gases also included in it. Anything that we want to do it, we need to think about all these triple bottom line aspects. And we also need to think about life cycle stages. A lot of times, civil engineers, we think, we will have materials magically come to the site, we construct it, and we start maintaining, and after that, we're going to dispose of. Not like that. So we need to think about what are the resource extraction, like going back to mining, manufacturing of the materials, and then on-site construction, maintenance, and then after demolishing, how much you're going to recycle, how much you're going to dispose. So we need to look at impacts at every life cycle stage. So, that gives you the true picture. And this kind of assessment is called life cycle sustainability assessment. And this is how every project needs to be looked into going into the future. We should be teaching our students on performing such analysis and making the decisions on what is the most sustainable design. So if you are interested in learning more about this methodology, I suggest you to look at this book that shows this concept. Just to give you one example of how this can be done. For example, I have a multi-story building and I need deep foundations. And you have done site characterization, the soil profile, soil properties. And you have two types of deep foundations, pile groups or caisson or drill shafts. Those are the two common types of foundations for high-rise buildings, tall buildings in Chicago. So, and then we teach in our foundation design how to design these things, pile group and caissons or drill shafts. And you can design that one. That's the design summary. So which one to use? Because both of them, piles or drill shafts, they equally work well, right? So they will support the structural loads. So which one is more sustainable, right? So if you do the sustainability assessment, looking at the environmental aspects, economic aspects, and social aspects, and combine them through the framework and calculate the sustainability index, piles come out to be lower, and caissons or drill shafts come out to be higher. So higher the number, better it is. So in this specific project, caissons come out to be, drill shafts come out to be more sustainable. But of course, I just want to caution that it's not true all the time. So it depends upon the project specific conditions. So in other project, it may be the other way around. So you take project specific information in this assessment and then come up with this kind of conclusion. So this is how this is a life cycle sustainability assessment. Based on that, you are, suggesting which one to use. So this is what we need to do. So if you suggest, this one to be used, so you're going to minimize the environmental impacts, you're going to achieve good economic impacts, and you're also, achieving a positive social impacts. So that's how, we need to think about it. Now, ideally, the triple bottom line is the sustainability, but we need to also think about resiliency in the short term. So we should be looking at sustainable and resilient, because the climate change impacts, we're going to feel it for a while. So we need to be looking at both sustainability and resiliency. And then we should be thinking about nature-based systems which have more potential to be sustainable and resilient. So now these nature-based solutions have less energy, need less energy, consume less natural resources, reduce pollution, adaptable, resilient, cost-effective, and socially acceptable. The only problem is a lot of geotechnical engineers or a lot of civil engineers, they don't learn these things. They didn't learn these nature-based solutions. We always use concrete and steel. So learning these nature-based solutions, it requires interdisciplinary background. You don't have familiar methods and tools, lack of past experience, uncertain long-term reliability, and there are complicated microbial and geochemical processes that you need to understand. So, but a lot of people are going after these nature-based solutions in the US, and a lot of emphasis uh, going on right now. Just an example I want to mention. So this is the seawall. Conventionally, we put this concrete wall. Okay, we calculate what is the surge height, and then we decide the height of the wall, and we design it. But the problem is nobody can certainly say that the surge height is going to be that much, because these climate impacts are unpredictable. It could be more than that, or So the nature-based solution is like this, where you create like a park. Okay, you don't have the wall and you don't put any infrastructure close to it. You keep the infrastructure far away from the coastal area as much as possible. There are restrictions on having any infrastructure in certain distance from the coastal areas. And then if you have a park like that, if you have the hurricane or sea level rise or a surge that comes in there, this park gets flooded, and then when it recedes, it goes back. So you don't have any damage, and you don't have to worry about anything. So these things are becoming more and more common. So in geotechnical engineering, in civil engineering, we should be thinking about these nature-based solutions going into the future, because they are sustainable, because they will use less resources, less energy, less pollution, all those sustainability factors come in there, and also resilient, because this a change in the climate conditions, these things can withstand. So with that one, I want to just close my presentation with these comments. So I try to explain what is geoenvironmental engineering, how it evolved, and then I explained what are the challenges, and the challenges gives you the opportunities, and the opportunities come under waste management category, contaminated site category. Then you have a climate change and resilience design category, and then you have a sustainable design category. And then obviously you want to combine sustainability and resiliency together. So there are a lot of excellent opportunities to do things differently, because we have no choice but to do things differently. So for me, geoenvironmental problems are very important to address, because they're posing the risk to public health and the environment, as well as to sustainable development. So geoenvironmental engineering involves developing innovative, sustainable, and resilient solutions to the geoenvironmental problems. There are a lot of research opportunities. If you're a faculty member or if you're a graduate student, you can think of many, many different opportunities in this one. And geoenvironmental engineering requires geotechnical engineering plus some other multidisciplinary knowledge. So that could be a challenge for some people, but for some people it could be an excitement to learn other than the civil engineering stuff and the geotechnical engineering stuff. And I want to emphasize that we should be teaching geoenvironmental engineering course for our students to be able to make them aware of geoenvironmental problems and the need for coming up with a creative solution. So there needs to be a curriculum improvement in geotechnical engineering, particularly if you're teaching a geotechnical engineering, think about offering a course in geoenvironmental engineering for undergraduate students, and maybe the same course for graduate students, MTech students, maybe advanced course, to graduate students, MTech and PhD students. And resiliency and sustainability are the buzzwords. You cannot escape these words into the near future. So they are imperative and they must be considered in all engineering projects. So in civil engineering, any branch, even mechanical, chemical, every field, they need to consider these things. But even, more important to consider these things in geoenvironmental engineering projects. So with that one, I hope I gave you a lot of information about geoenvironmental engineering, geoenvironmental challenges, and geoenvironmental opportunities. And I hope you will pursue some of these topics, for your research or for your teaching activities. But if you need any help, I'll be happy to provide that help. This is my email address, and these are my lab websites. Please go to these websites and you will find a lot of information that you can download. I'm on Twitter, Facebook, LinkedIn. You can connect me. So we'll be in touch with you on these things. And then if you want to know more detailed research on a particular topic,